he puts in more years than he can remember or likes to remember. But he still considers himself a relative newbie compared to the people that founded the club back in the mid-1980s. Jack's interest in space and science goes back to his childhood. He told me a story of when he was 13 years old. He actually wrote a letter to Chris Kraft at NASA, the NASA flight director, with an idea he had. And Chris Kraft actually answered him. And the letter basically said, please study physics. So Jack went ahead and did that. And he's worked as a Unix systems engineer. He retired in 2018, currently serves as president of this club, and Jack often gives talks to outside groups. His topic for tonight, usually our topics are very heavily science-based. Tonight's not going to be one of those nights. Jack's title for this topic is Bad Science, Bad Astronomy. A short study on weird ideas in science and space. Sounds like an interesting take. So there you go.
Thank you. Thank you. Wow. Feels like right back where I started. Bad science, bad astronomy. Why do people have strange ideas? Now, and why should we care? Now, since I did sort of steal the idea from this guy, I feel like I should give him a little bit of credit. I wish I could get this thing to go away. There it goes. This is Phil Plait, and this is his book, Bad Astronomy, which I picked up around 2002 or 3, just after he wrote it. I've been paying attention to a lot of his work. One of his talks, I've invited him to speak here, by the way, and it has to be in association with something else because he gets $6,000 to talk. And I figured if he goes and talks somewhere else, then he's happy to come to local astronomy groups afterwards. But I'm tired of ignorance, held up as inspiration, where vicious anti-intellectualism is considered a positive trait, and where uninformed opinion is displayed as fact. That's the basic concept behind this. His book, Bad Astronomy, was his first shot at that in a written form. Book explains and corrects many ideas relating to space that, according to Plait, are mistaken but nevertheless portrayed in popular movies. Phil Plait dedicates much of the book to debunking the idea that the moon landing was a hoax, and he explains why astrology should not be at all taken seriously. I think he uses the wonderful Randy situation with that. A part of the book describes the moon's tidal effects and explains the Coriolis effect, why the sky is blue, Big Bang, and other related topics. It was probably my starting point for debunking things in general, outside of my personal vagaries with the religious. And then, of course, because there's always an XKCD, I was actually looking for the opposite of this, and I was dismayed to find that he didn't have one. Well, I actually did. So there's a little thing called imposter syndrome. Imposter syndrome, illustrated here, where Dr. Adams is being introduced, social psychologist, world's top expert on the imposter syndrome. Don't be silly. There are all sorts of scholars who made more psych. Oh my God. In other words, she's experiencing it. And this is the subtext. This is what I was looking for. It's actually worse than people who studied Dunning-Kruger effect. We tried to organize a conference on it, but the only people who would agree to give the keynote were random undergraduates. That's because Dunning-Kruger is cognitive bias in which people with limited competence in a particular domain overestimate their abilities. In other words, me. Okay. So, Richard Feynman, also one of my heroes. First principle is you must not fool yourself, and you are the easiest person to fool. And I stuck this up here because it's really common fodder to deal with the flat earth people. But here's a picture of the flat earth, picture of us being fooled. And a lot of us have seen this, right? Matter of opinion. You know, guy over here says it's a 6, guy over there says it's a 9. Well, they're both right? Excuse my inability to do graphics, but why did it get bigger? There we go. If it's preceded with something that means something else, in this case, the first few digits of pi, then it is no longer a matter of opinion. Okay, one of these guys is wrong, simply and absolutely. So astronomy is a science, and like all science, there's rules, sort of. A science is a system of knowledge that is concerned with the physical world, its phenomena, and it entails unbiased observations and systematic experimentation. In general, science involves the pursuit of knowledge covering general truths or the operations of fundamental laws from Britannica. So, rules then. Well, typical application of scientific method, a researcher develops a hypothesis, tests it through various means, and I'd actually like to say I get an idea before I get a hypothesis. Idea is like something popped into my head. Hypothesis is like, I wonder if I can make something out of this. Test it, the hypothesis through various means, modify the hypothesis, repeat, lather, rinse, repeat until something happens to it. And graphically illustrated like so. Ask a question, construct the hypothesis, perform the experiment, analyze the data, get a conclusion. Is your hypothesis supported? Well, try another experiment. Is it unsupported? Well, go back and change your hypothesis. Basically, what that means is you're trying not to fool yourself. And what you want to try and do, well, if your conclusion is supported, well, do you go out and tell the world you just found something? No, you try and make it wrong. You try and find a way to break what you have come up with. If you can't break it, then it is legitimately supported. Doesn't mean somebody else can't break it, but at least you try the first step of things. But astronomy for us is really just observation, unless we're trying to make a living at it. And probably most of us here aren't necessarily. We don't really often have a need for full rigor of scientific method, but we can still make use of it that others have applied, so we can understand the way things work and base our understanding of the larger universe on the work of others. So what do we make of people who, and using this as a kindly way, thoughts that run up against what we know or understand? The flat earthers, moon landing deniers, people who wonder why there's never been a photograph of our own galaxy from the top down. I've heard that. I tend to group these people into one or more of these categories, maybe a few other ones. Person is pulling my chain. They're not serious. They're just trying to see if they can get me going. It's very easy to do. I've been sitting in a room making things up. I had a very long discussion. I think finally I've shut him up about such a event or such an idea where a person was had a particularly strong understanding of something that does not happen, can be shown not to happen, didn't matter, absolutely believed that this is where everything came from. And it took a lot of no, things don't work like that to get him to at least stop calling me. Maybe he's calling somebody else now, I don't know. Someone who's actually trying to learn something, but maybe has listened to the wrong people. Okay. There's a few of those running around. Someone who's actively trying to learn something and is actually trying hard to understand, but maybe doesn't have all the particulars. And finally, a person who knows way more than I do, in which case I tend to try and listen to them and not argue with them. I've had some influences along the way. Good to Bad Astronomy. William Gratzer, The Undergrowth of Science. Neat book. As it says here, we think of scientists as sober, precise thinkers. A lot of them got some really strange ideas, and a lot of them really tried to push it. N-rays, vitamin C cures everything. Undergrowth of Science is a recounting of several of the blind alleys. Scientists who went through the correct process and ended up with the wrong result. which is very, very neat. Another book called The Borderlands of Science. This is very similar in scope, but with a different set of people. This is the set of people who want to believe whatever it is they want to believe. The book starts out with a thing called remote viewing. A guy, and this was, I think, in the 70s-ish. There was actually a CIA project going on with this to get people to remotely view Russian, armaments and things like that. And the guy was actually teaching people how to do it. And when Shermer went to the first event of those, he was they had a little training session of how to do it, and they had one guy out in the audience, shouting about what he was actually seeing it. And he said, "That's an excellent hit, really marvelous." Turns out he was a friend of the guy. They rode in together, and they were talking about the lecture. He knew what this presenter was going to be presenting and where his goal was. So Shermer was talking about it, and he was seriously interested. He wasn't trying to debunk the thing. He was like, "This is interesting. I want to see how this goes." So the guy invited him to provide the source. And I thought it was neat because the source that he comes up with is M31. He's going to have people go to M31. Of course, he's the only one who knows this now. And as it goes, of course, nothing works, because I had a relative in the family one time who was convinced that he could see things from far away. And I asked him, "What's the mechanism? Where are you getting this information?" I could tell you where you're getting it from. You're making it up in here. It's imagery. It does not actually exist. You can't see it. And it's been shown all repeatedly through one of the interesting ones. I thought there was a sense that people would leave their body if they were just about to die, and then sometimes come back. So one of the doctors put a clock on top of a cabinet facing upwards. And the person felt they went out of their body and came back. He said, "Oh, what time was it?" And of course, nobody saw the clock because they didn't know it was there. But Shermer's book is that. It's talking about where fuzzy science begins. Now, there was another one that I actually got kind of much earlier than all these. This was a television show that some of you might have actually seen, called The Ring of Truth. And is everybody familiar with the Ring of Truth actually refers to? Basically, from the book itself, when gold coins were much used in commerce, experience suggested that the ring of the metal on the tabletop could exclude some base coins whose weight alone would not let them pass. People were making gold out of lead, coloring it gold. It was prudent and even satisfying to test for the ring of truth, which had a coin. Ding! Some counterfeits, though, rang true, but it was an approach to the truth, which is about all anyone can expect. That's straight from Phil Morrison. I set out watching. My intent was to watch all 6, I think, events in the series. I did have one, but I became rather confused as to what my point was on it. It was the 6th of the series, called Doubt, strangely enough, because he doesn't actually bring up doubt until the very last minute or two. But the entire first sequence is observing the Pleiades and observing other stars and learning how to take spectra, and from the spectra getting information about how things are moving in space. And the latter portion of it is spent mostly with Vera Rubin. And he's out there with her, and she's showing him how she took spectra of, I think it was M31 again, to tie it together, and how she noticed that things were not moving at the right rates, the rates they should not have been. And she basically said, this is where we figured out what dark matter was. Absolutely phenomenal. But from the start, I mean, these are absolutely wonderful treatises on physics, sort of indirectly, maybe directly, but realistically, how we know what we know. Inquiry, the subtitle, Inquiry into How We Know What We Know. Fascinating stuff. You can get them out on YouTube. The video is horrible. And oh my God, wait until you see the computers. This thing was written in, I think it was 1986. So yeah, computers are amusing. But in any case, that's Phil, and I'm not going to play that video because I don't have enough time. Now, oddball ideas, but not all oddball ideas are wrong. Just because something goes against an orthodoxy doesn't mean it's necessarily wrong. It is, however, usually the way to bet. Now, this is an example of oddball idea that, well, I'll let you decide. Anybody heard of the Channel Scablands? Couple. Cool. Neat place. I'd never heard of it. I'd been out there. This is a picture roughly of the area that they're in. You've got Seattle parked over here in the west and Spokane over here in the east. And this kind of...
LIGO's in there.
What's that?
LIGO.
LIGO. Yeah, LIGO's probably in here somewhere.
It is.
It's somewhere.
I see it.
I don't have a spot on it though. So it's a very odd area though. The Channel Scablands is an area, it's approximately 16,000 square miles. And no one really knew how it got there. In the text here is in the middle of eastern Washington is a desert that gets less than 8 inches of rain a year. It stands what was once the largest waterfall in the world. It's 3 miles wide, 400 feet high, 10 times the size of Niagara. Plunge pools at its base, suggesting an erosive power and an immense flow of water. Today, there's not so much as a trickle running over the cataract's lip. It's completely dry. First farmers in the region named the rocky parts Scablands, dismissed them as useless. Geologists were not so dismissive. To them, the Scablands were an enigma. They didn't know how they got there. There wasn't enough water. It looked like a water formation. They knew what the Grand Canyon had been created. They knew how that had happened, but they could not get this to figure out what was going on here. The features out there are just incredible. These holes on the lower right are nearly circular holes that don't have any obvious methodology of being there. So in about 1909, this high school science teacher named Harley Bretz visited the area and was absolutely taken with the landscape, and basically went to the U.S. Geological Survey to see their new map that they had created. He was 27. He didn't have any formal training in geology, but he noticed that looked like a huge cataract, like the Dry Falls on the western edge, the place where the water appeared to spill out of a basin into the Columbia River, gouging a canyon several hundred feet. The falls would have been bigger than Niagara, but there's no apparent source of water, no sign at all of what was going on here. You do have a little trickle, a little lake, but nothing like what we really need to get in there. But he did notice that we had these little ripples in here. Well, these little ripples are, let's see, it's in here somewhere, 30 to 50 feet high. They're not that little. He figured that there must have been a massive source of water, but he couldn't find it. Just no water anywhere. The amount of water he needed was on the order of 2 of the largest of the Great Lakes, or better, right? Person in the corner for scale. Yes, I forgot that. That's how. There's that little ripples. There's the guy, human, in the lower left. Yeah, these things are massive. So he became a geologist, took his PhD, and he returned to Washington State, developed a hypothesis about how he was going to do this. He still didn't have any real proof, and it was basically geological heresy. He did a presentation to a geological group, and they roundly ridiculed this guy until he found an individual who pointed out that during the Ice Age, there was this massive amount of water held out through an ice sheet, held up by a wall of ice. And the postulate was that this wall of ice eventually broke as things warmed up. And this huge amount of water came cascading down through the area, ripping things up. Those round holes were cut by rocks being spun in turbulence. And they were just spinning and just drilled holes in the softer rock under them. So the idea here being that he had to wait until, I believe it was like 1950s. It was a very long time before he was shown to be correct. So he had this wild, crazy, absolutely stupid idea about how something happened. And he had to wait to find one little tidbit of information where that water came from in order to be able to show that he was correct the entire time. So now, when we talk about things, we can get a long list of, or short list rather here, of logical fallacies. A fallacy is a use of an invalid or otherwise faulty reasoning to construct an argument. All forms of human communication can contain fallacies. There's formal fallacy, formal logical fallacies. They're all forms of non sequitur, meaning it does not follow. The appeal to probability. I've been playing this damn game all night. I'm due to win, right? The argument from a fallacy. The example they gave was, you cannot borrow my car because it turns back into a pumpkin at midnight. If you really think that, you're an idiot. That's an ad hominem. Therefore, I can't be an idiot. Well, I beg to differ. The car is not going to turn into a pumpkin at midnight. The non sequitur itself. People generally like to walk on the beach. Beaches have sand. Therefore, having sand floors in homes would be a great idea. The idea doesn't follow itself. Some of these a little far afield for what we go through tonight, but base rate fallacy is only 6% of applicants make it into the school, but my son is brilliant, so they're certainly going to accept them. It doesn't always look that way. And then a conjunction. This is a bit weird. Not going to worry about it too much, but basically it says if something is a member of a larger set, then the probability of something happening outside of that set is different than being inside of it. The example they use here is that while jogging around the neighborhood, you're more likely to be bitten by someone's pet dog than any member of the canine species. And of course, the fallacy is that dogs are not members of the canine species. So misunderstanding on what's going on there. And a masked man, which is creating a lady in a pink dress is Julia Roberts. Or someone thinks the lady in the pink dress drives a Prius, therefore Julia Roberts drives a Prius. So the first three are probably the most common for what we'll go through shortly. The appeal to probability, argument from fallacy, and non sequitur. Maybe not all of them, but in there. Informal fallacies. There's a few here. There's a few more there. Burden of proof, continuum, equivocation, the fallacy. The fallacy of quoting out of context, begging the question. Some more, furtive fallacies. This is a short list of some of the less formal fallacies. Special pleading. Texas sharpshooter is fun, especially with a picture that Eric has on his wall. Texas sharpshooter is basically where you have a whole bunch of data spread out and you pick this right here. You say, that's meaningful, so therefore that's the only thing that counts. So lots of possible fallacies to deal with here. Yeah, some bad science finally. Things like this. These are things that I've found either out on the website of Quora, which we'll get to in just a moment, or heard from people or other things. But common one is, why isn't the mathematical value of pi exactly 3? Now, I need to point out that in Japan, they used to actually teach this as an approximation method, probably do in some other places too. I don't know.
It's the biblical value.
It's the biblical value, exactly. Problem is, of course, that it isn't exactly 3. But if you want to get a close approximation of something, you could actually use it. This is fun. If the Earth is spinning at over 1,000 miles per hour, how can all the water stay in the oceans? Much less, how can we stand on it, right? Interesting thing brought out to me. I never thought of it this way, but somebody said, look at the hour hand on a 12-hour clock and realize that that hour hand is moving twice as fast as the Earth is. So matter of perspective, matter of mass. This was a good one. I generically assigned. I figured everything out, wrote a paper, and got it published. This is actually almost word for word straight from Quora. No one cares. Why are scientists like that? Okay. That is pretty close, except for the problem was he couldn't write it out. But that was pretty close to the event that I had with someone local. They couldn't write it out though, so they wanted me to write it out. My problem was I'm not into science fiction. I did try to get him to go that way though. Asked him to read Terry Pratchett's Discworld, because Discworld is a marvelous treatise on how to make an absolutely wonderful story out of a really wacky idea of a flat Earth. Others can get more interesting for suitably large values of interesting. I just clicked on Quora this morning and came up with this one. What if I step on the sun? And that was just there. You know, you click on Quora, it'll be something else right now, but I thought that was fun. And the answers usually go on to, you know, well, if you can avoid being incinerated instantly, they go into some description, sometimes good, sometimes bad, about what will happen to you if you were able to do that. As people have a tendency to believe that if it's out there and I can see it and it's round, more on that in a minute, maybe, then I should be able to stand on it, right? Well, not on a ball of hydrogen. More examples. This is good. Why didn't NASA see Atlas, the comet that, and this is not someone saying, oh, this is what Atlas is. This is what was in the actual post. The comet that is roughly half the size of the sun, that will come within 70 million miles of Earth before. And we could go to the link here, but I'm not going to bother at the moment because of time. But the essence of the idea was the comet isn't half the size of the sun. Probably the coma wasn't half the size of the sun. But from our position of observing it, they may have angular distances which might be approximately the same. But, you know, that's when you do I can't remember the father things. There's a neat little thing they spread around the world where the guy's sitting there, he's a cow, and he goes, close, far away. He's like, the cows are that big because, you know, that's the size of them.
Grover did that on Sesame.
Yes. So, of course, I think most of us understand how angular distance, how we see the moon as a half a degree and the sun as a half a degree. It does not mean that they are the same size. It means that the angular distance, they have a nice picture of, you know, us standing here with our line of sight going like this, and the moon was here and the sun was out there, and they were the same because our lines of sight intersect at that distance. Moon landing is a favorite of them, but this was a different one. If the 69 moon landing was real, then why did Challenger blow up in 1986 after passing through the firmament? I don't know why the person related an event in 1986 as being unable to get somewhere to an event in 1969 of being able to get somewhere further, but they did. This is a little bit of the, you know, are you being real here? Love this one. Moon does not reflect sunlight. It has its own light. Various proofs of this are that if I hold up a rock, it doesn't glow. Therefore, it's not having its own light. The general answers are, how are you seeing it? One good one was go into a room, turn out all the lights, make sure there's no light, make sure that you can't see anything, and turn on a flashlight. And you know what happens? You bounce onto the ceiling, you see the whole room. That's called reflection, or albedo in the scientific world. And the moon has quite a bit of it. Thank you. I was going to look up the albedo of the moon. Earth is 0.39, but is the moon more or less?
Probably higher. It's pretty light.
Yeah, I think it might be a little bit more. I thought the Earth might have been more. Albedo of the moon.
It's like
6.6. Yeah.
6%.
Yeah, 6%. 6%.
It's as bright as
Well, we're
asphalt.
30%. Yeah.
It's as bright as asphalt.
Okay.
That's slate.
That makes sense.
Black.
Cool. And yet still bright. I always thought, well, you know, you take a mirror and shine the sun off, you know, the mirror into somebody's eyes. So that's close to 100%. Now let's put something darker and get you down to 50 and see if we can not blind you. Yeah.
When we're covered with snow.
Yeah.
A little higher.
Yeah. But the idea being that folks of this standpoint don't understand how we see, really. Old concept that we see by emanating rays from our eyes, and that's what allows us to see. No, it's the bouncing of light and everything that we see. Vanta black is the closest thing I think we've gotten to not being able to see something. And I understand from people who've seen it, it's really spooky to look at something painted with Vanta black because it's not reflecting, you know, I don't think it's even a tenth. It's a tiny amount of light that's coming off of this thing, and it's like you're looking at a hole in space that you know is there. But anyway, there were several questions on Quora about that one. Oh, this was a fun one that we heard just a few days after the solar eclipse. How can the moon have covered the entire sun during the eclipse, but only a few days later, it's just a small crescent? Okay. I had to think about that one for a minute. But, you know, of course, they think that the glowing part of the moon is the moon. And this was made very common idea by pictures of religious figures standing in the moon, you know, crescent of the moon, and they're on it like this. And we've even got movies that start off with some kids sitting on the moon, you know, crescent, throwing his fishing line in. And that's another fun thing that Phil Plait did. He loves to debunk movies. And he said, I've been watching this all over and I never noticed the one thing wrong with it. I mean, aside from the kids sitting in the moon, which you can't do. He said, when they pan down from the kid to the surface of the water, the stars are the same. They're not reflections. They're not inverted. So you can check that out next time you see that. I forget, Amblin, is that? Okay. But in any case, you know, again, differentiating the reflected light from the moon from the actual physical aspect of the moon, which doesn't really change, smaller and larger slightly. But mentioned this one earlier, I think. Why has NASA never sent a probe to view the entire Milky Way galaxy? People have a tendency, I think, to feel that if you can see something, it must be right there. Now, I've had this happen to me. Who's been to the Grand Canyon? A couple of folks. Are you familiar with Bright Angel Point? It's a place from the South Rim. It's a point down on the river that usually tie horses. Nothing really neat. It's just Bright Angel Point, neat little place. You can sit by the river, whatever. I had never been to the canyon before. I was with someone who had and knew it. And I had no water, nothing. We looked down. We're walking down the canyon. It's about 11 o'clock. We started out about 11:45. Person says, I've had enough. I'm going to go back up. I said, well, you know, I want to go to Bright Angel Point. It's right there. I can see it. Long story, it's a crazy story, insane story. I made it. I did go. A lot of sideways things. I had some rules because I had no water. I had no food. They have watering stops, 3 on the way down. Indian campground has water. I stayed at each one for a certain amount of time, made sure I was hydrated a little bit. Came back up, another funny story. I got up to the rim and I saw the sign that I missed on the way down that said, if you are in unbelievable, outstanding, you know, super unbelievable shape, triathlon kind of person, this trip takes 12 hours. If you're in good shape, good hiker, plan overnight, stay 24. If you've never done this thing again, don't do it in less than 2 days. I had just done it in 6 hours. From top to bottom, Bright Angel Point, and back, plus a little bit, in 6 hours. I will tell you, when I got to the top and was looking for my friend, my legs spasmed and I had knees here. It was very painful, but I did do it. I did not have a sense of distance. I did not understand that seeing that thing right there was actually more like 12 miles away because I had to get there this way. So when people think of the Milky Way, they think of the solar system. Another common question that's not in here is how many stars, you know, do we have in our solar system? It's another reason why we think that aliens haven't visited, because we've only got 1 star on Yelp, I guess. I don't know. But anywho, we have a tendency to believe that when we talk about the solar system, we're talking about, hey, this thing we're standing on, and the rest of it must just be right there. Look up and I can see the stars are right there. Not to those of us who know the depth. We're talking 1,000 light years. We're about in the middle, and our farthest, fastest thing, which we'll get talked about next month, is Voyager, that is almost, but not quite, 1 light day away from us, and been traveling slightly less than 50 years. Yeah, a long way to go. This is fun. Elon said we could cut the travel time to Mars in half by reaching Mars halfway there instead of where Mars is located. Now, that's the question as it was asked. We're going to get to Mars by going halfway there, and we'll be there. We think the people who have answered this believe that what the questioner was saying was that we will accelerate constantly out towards Mars, or towards the path to Mars. And then when we are halfway there, flip, decelerate. We are all pretty well familiar with that methodology. Very, very costly in terms of fuel, but that's the way to get there as quickly as you can. But the way that these questions are asked sometimes can lead you to scratch your head. You sometimes have to go back. I could not find the actual Elon Musk quote on this, but I think that it basically supports the fact that he was saying, I think we're going to go accelerate halfway there, and that will cut our time down.
There's ion drive.
That's what I was.
Ion drive, yes, exactly, with less power behind it, but yeah, that's the way to do it. Is a slow, constant increase in thrust. So if we can make that workable, large scale, that would be the way to go. And you get, gravity comes along for the ride. Not much, a little bit, yeah. It's another thing. It's not in here, but we talk about, oh, we're going to put the centrifuges on these things. It ends up having to be really, really big, or you suffer from Coriolis, where your feet are moving much faster than your head is, and you get all vertiginous and get dizzy.
I think somewhere a long time ago that people can tolerate as much as 1 RPM.
That's probably true. It depends on the size.
Yeah. No, 1 RPM is.
Oh, okay, right. If you have a great big ring running 1 RPM, that's going very fast anyway. So yeah.
If it's 1 RPM to get to 1G, that gives you a particular size. But you could have a smaller ring and just have less gravity.
Yeah. So the bottom line is, those of us who watched 2001: A Space Odyssey, that centrifuge they had in Discovery probably wouldn't have worked.
Well, it would, but
It would, yeah.
as long as it's slow enough.
Yeah. So anywho, it was early special effects, so we can deal with that. Can we capture the Voyager space probes and return them to Earth and put them in a museum? I'm not making these up. People are asking this. Yeah, we have to, discuss the fact that it has been traveling almost 50 years. It is going very, very fast. I do have a note in here, I think, about how fast they are going. I think they're like 35,000 miles an hour. I don't remember. It's they're outside of solar escape velocity, things like that. So, anywho, some of these are just more fun to read than they are to look at the answers. This is weird. Here's a thought. If there's no terminal velocity in vacuum and things keep accelerating, why are the Voyager probes not traveling at nearly the speed of light? This is a bunch of logical fallacies altogether. One of which is, I don't know what no terminal velocity in a vacuum necessarily means, but in theory, you could just continue accelerating because there's nothing getting in your way except small, very, very tiny particles, which suddenly have extremely high energy because you're hitting them so hard. But the other thing is that things don't just keep accelerating, of course. We have ways of making them accelerate after we've run out of fuel, planetary slingshot assists, or the other direction where we retard. And of course, the Voyager probes have only been accelerating for a very short period of time until they meet a planet that's capable of giving them a little extra push. Some lovely charts of how these things happen. But again, people have the tendency to think that, well, it's out there and it's going away from us, so it must be accelerating. And if it is accelerating, well, then how come, it's not, what percentage of the speed of light is that already? So it's a conglomeration of a bunch of very strange ideas all taken together to make a very odd question.
It would have to be continuously decelerating very slowly because the sun's still full.
Well, yes, and actually is, yes. Yes.
If you could reverse gravity of the sun, then
yeah. Turn the sun into black, dark energy.
Know enough to realize they can't exceed the speed of
light. Yeah, nearly the speed of light. Yes, yeah. Well, yeah, they go there too, but how come we can't? When one of the questions I got in here once, not in here, but a little sidetrack, is if we could be around a black hole and and orbiting a black hole and lower a rope in, beyond the shield, then we could pull the rope up. And I said, okay, but my first problem with that is you can't just, if you're just outside, the short sail radius, you can't just sit there, you're not cooling your heels there. You have to be moving at an orbital velocity that keeps you out of that area where you ain't coming back. So you're already clicking along, and anything that you lower into that is going to gain mass to some incredible amount, and basically gets infinite once you get past the short sail radius, and yanks you in.
Black hole, like interstellar, they got planets around the black hole.
Yeah.
Let's go live on one of them. No, there's not much energy that a black hole provides, like the sun, that would be useful to us. And there's a whole lot of energy that is very, very bad.
Yes. Of course, I didn't, got to admit, I didn't see Interstellar, but I did read a lot. No, I never saw it. I don't, I don't like the things that are that strange. But it did have Kip Thorne doing the science for it.
It's the best.
And before we had imagery, they actually thought about what it would look like and came out with an outstanding, very, very close to reality
That's why
visualization.
Accepted the job, is because they had all these computers that he could use to visualize it.
Yep. And we had to wait a few years, but damn if he wasn't right, And there's a wonderful set of videos. This guy's name, Steve. Can't remember his last name. Such a name, I think. He's not the smarter everyday guy. He's not. I don't think he's the Veritasium guy, but he's one of those. I'll think of it in a minute. But he does he has a wireframe thing about, he has a little black piece of paper in it for simulating the black hole. Is that Roman Legion ordering 5 beers?
Yeah.
Yeah, I know. I'm getting there. I'm almost there. But he has a really excellent way of showing you how light gets to us that way. That's very graphic and lets you understand it. Now, some other strange ideas in many different places. Why does the moon cause tides and bodies of water, but not coffee, and not in my coffee cup? Okay. And yeah, I was going to say it does. It's just that you're going to have a very hard time measuring it. It does on you too. I've only recently really found I had a age-old question about why there's 2 tides in different places on the earth, and I had a lot of misunderstandings about tides myself. But instead of making up stories about them, I kind of figured it out, and it was really kind of cool because the moon is more effective than the sun, but they can get together. But generally speaking, the moon is going to pull the water towards it, but then there's an opposite side of the earth tide out as well, and that's because the moon is pulling the earth as well. It's pulling it away from the water.
Yeah.
So that was kind of cool.
All right. Do you know the magnitude of the flex of the earth through the tides?
I don't, but there is.
So that much.
the Earth is really flat. I have all the proofs. That's
Yeah,
everywhere.
like by a foot.
Yeah, yeah, and you know, the tides bend us. They bend everything as well. We mentioned that before. The moon emits its own light, not a reflection. This is a very long period of time I wrote all this, so I got a few repeats in here. Mankind has never gone to the moon. And the proof of that is we can't see any of the landing sites from Earth. Of course, I think every one of us understands why that is here. The thing is, they never actually,
A long list of other things that.
yeah, they never actually go to the Lunar Reconnaissance Orbiter site and actually do see the landing sites. So,
We didn't have the technology.
yeah, oh God, yeah,
We
couldn't
didn't
get
have
through the
the
Van Allen
technology
belts.
to take it.
Yeah.
Very effective.
Oh, there's another one that goes on about rockets can't work unless they're launched from perfectly flat space. So therefore, the Earth is flat, yay, or rockets don't work. And one of the responses to that, I didn't keep it because I couldn't find it again, but one of the responses to that was out in space, a rocket actually pushes off of its own gases. And I'm going, that's not even a right answer, you know?
There's
So,
there's a New York Times editorial chastising Goddard, making fun of him for that exact reason.
oh yeah, yeah,
That anyone knows that in space, there's nothing to push against.
yep. Comets have never been shown to contain any water. Why do we call them dirty snowballs? It's fairly simple, although maybe not obvious to the most casual observer, to get lots of spectrographs on cometary materials, and many of them, though not all, have a tremendous amount of ice and water ice, H2O. There are other versions, lots of other different kinds of ices, but majority of them have water.
So in Roger's class, he also has me make CO2 snowballs.
Yeah.
And they look like a snowball, and he throws it against the wall, and then it evaporates.
Yeah.
It's a big hit with the kiddos.
And one that I could swear that I got here, but nobody will own up to it. You can achieve Earth orbit by thrusting at only 5 miles an hour. This came about when I basically was talking about how to orbit, discussing how we get into orbits, with premise to starting up in the black holes. And we were talking about, orbital velocity, escape velocity. And somebody said you can escape the Earth at 5 miles an hour. And of course, I was up here doing this. So, it wasn't, I'm like, okay, let me think about that. Went home later and kind of worked it out. Now, this is a couple of fallacies here. First of which you see a lot on Quora is, you go into orbit by going up. If you just went up, straight up from the Earth and cut your engine, you would come straight back down. You would maybe not hit exactly where you left, but you would hit the Earth somewhere, because going up is just really so that you can miss all the stuff in the way when you hang a hard right and start going sideways, because what you need to do, and Newton figured this out long ago, is go fast enough at a certain altitude to continually miss the Earth as you're falling towards it. So the idea was, well, let's assume that you have infinite amount of fuel, time, and everything else, and you just were accelerating, you were just thrusting at 5 miles an hour. Your movement was 5 miles an hour constant. How far away would you need to be? Well, you would need to be where the orbital velocity of the Earth is 5 miles an hour, which I worked out roughly to being, I get the numbers on here somewhere. Oh, here we go. It's about 1.5 times 10 to the 12 miles, or 15,550 astronomical units, or about 100 times the distance of where Voyager is right now, roughly speaking. And if you were there, then you could orbit the Earth, or something that looked like the Earth, at 5 miles an hour.
However,
comma.
5 miles per hour is not a measure of thrust.
It's that
Right, yeah, exactly.
That's a rate. Yeah. So anyway, whatever. How can we see planets and other star systems but not see flags on the moon? And then again, I mentioned this earlier, sometimes we can see planets and other galaxies, but we can't see the flags on the moon. I think most of us here understand angular resolution. I did also work out sometime close to when I was doing that 5 mile an hour thing, of the size of the eyepiece that you would need if you had an 8-inch telescope on Earth, completely disregarding all optical physics at all, just saying, what would you need? And I think it was, if I remember right, it was something like 0.000175 millimeters. And it was not realistic. And the one that started this whole thing off.
Well, wait, before we go to that one.
Yes, sir.
Have we seen a planet in other galaxies? Have we gotten to that point yet where we can detect them in any?
I'm going to say no, but I don't know.
I thought I saw.
Furthest exoplanet was discovered by my daughter. It's 30,000 light years away.
Really?
It's in this galaxy.
So we in the Milky Way,
That we've measured, actually.
but it's still in the Milky Way.
Well, I would think that any star that we can measure the brightness of with accuracy, we could detect it.
But I don't think
But
we see
we-
individual stars in every galaxy.
Right. That's what I was about to say. We
Actually,
can't.
I see individual stars
That's
in
what
the
you're talking
Andromeda.
about.
Yeah.
Individual stars.
So this is how Hubble's law was determined by looking at Cepheid variables.
206, I think.
Yeah, we can see Cepheids. We can see individual stars.
So I think I saw a headline go by the last few weeks about seeing a planet, or evidence of a planet, not seeing
I-
the planet itself.
Yeah, I'm
But I did not
thinking
pay
that
attention.
too, but I
In
couldn't
in
go to
another
it. No.
galaxy, but
Yeah,
I mean, it's hard enough to see a supernova until it.
until
Oh,
it
yeah.
supernovas. Yeah.
The cluster, AGC 206 is a cluster, is a large of the cluster, which.
Well, let's look it up. Let's find out.
It's not called a cluster, it's called an association, but it's
Yeah.
very, very bright from stars in Andromeda. And yeah, you can see there may be 16th magnitude.
Well,
uh,
realistically, all you need is something large enough to give you the resolution, right?
No, it's a very large, it looks like a fuzzy patch in Andromeda.
Yeah, but to see a planet there, you need
Oh, a
you need
planet,
optics
yeah.
large enough to get the resolution required for
Yeah,
it, right?
yeah.
But
Yeah.
but most planets are detected not by direct imaging, but by transit method.
True.
Or
Transit
or
or
redshift.
redshift. Yeah,
Right, but
yeah.
that's,
Wobble.
yeah,
Yeah.
right, to see it is kind of a misnomer. but-
Yeah. I don't know. It's not impossible, but I don't know that we've actually got it yet. But we may have
And
one.
you can imagine that it might be possible as we improve the technology.
Yeah.
So let me finish up. I'm not too far away. My favorite, because it started me off on this whole thing here. Black holes can't, don't, won't ever exist. Here's proof, and bad math follows. Some of that bad math included orbits that excluded the speed of the orbiting object, so they were free to exceed the speed of light, and therefore proves that black holes don't exist, because this thing was able to come in and go out just perfectly fine, because my math said it did, except that I wasn't tracking the speed. So that started me off when a talk was given here in this very place. Now, I did have in here somewhere, there's supposed to be a warp graph. I don't know if this will play here because of the way it's behaving. But this is a neat little graph you can look up on your own. It basically says, well, what if warp, what if we illustrate the speed of warp of the starship as it proceeds from the sun outwards? And let me see if I can get it to play. Is that actually going out, I wonder?
Nope.
It is not? Okay. I'm not going to do it then if it's not sharing it. I can change the share.
Share the other
Bottom
one.
line is let's see, sun to finish 9.5 seconds. I think it says Proxima Centauri in looks like 32 hours. I can't really read it. But science fiction is a wonderful thing because you don't have to deal with real physics.
So I've never completely understood the warp system.
That's okay. No one else has either.
Yeah, completely.
I mean, it's not like, I mean, that was modeled on Mach number, but Mach 2
Yes.
is twice the speed of sound.
Right.
It's warp speed is calculated exponentially.
Yeah.
Right.
Yeah.
Speed of
Right,
light.
it's more like
Exponential
the
calculations.
In the original series, it was the cube of the speed.
cube of the speed.
So warp 2 was actually 8 times the speed of light.
Okay,
And then it's, if at the risk of sounding like a real nerd,
oh, yeah,
in one of the episodes, somebody did a calculation because they actually had, it's actually the speed of light cube times a constant, which makes it even a bit higher speed.
All of those numbers were
But it's
developed to
basically the cube of
make
the-
it so that they
but
could
then
get
in the
from
next
place to
generation,
place
they changed it.
in their
They keep
lifetime.
changing it.
to get higher speed.
Yeah.
Okay.
So then, of course, now, we mentioned that, how come we can't see images of the landing? Well, this is Lunar Reconnaissance Orbiter. I'm sure most of us in here have seen these images. The only trouble with us being able to see the landing sites on the moon is that we're too far away, so we put something closer to it. And this orbits, and let's see here, 21 kilometers from the moon's surface. So somewhat 14, 15 miles. And we can see the lunar module, and we can see the tracks and various other good things. So if you use the right tools, use the right analysis, you can see it. Now, you say, well, somebody asked, why can't we see Apollo landing sites? Well, resolution, field of view, physical light, we can ignore that. Resolution, telescope's ability to see this thing, blah, 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 math, both telescope and AIP's field of view, and so on and so forth. And landing sites are 385. There's this and that and the other thing, and this is a bunch of numbers. Is the person you're trying to convince still awake or even in the room? Okay. It's very, very simple to come up with a incorrect statement. It's somewhat more difficult to illustrate exactly how and why that incorrect statement is incorrect. What is the phrase? The lie is twice around the world before the truth is its shoes on. Something like that. Yes, exactly. So finally, the book I didn't bring with me tonight, I do have it. Forgot this one. Carl Sagan, of course, We're All Star Stuff. Science is a Candle in the Dark, from the Demon Haunted World. Absolutely wonderful treatise on explaining that science is not just a body of knowledge, it's a way of thinking. Sagan shows how scientific thinking is both imaginative and disciplined, and it brings humans to an understanding of how the universe is rather than how they wish or want to perceive it. I can't go into why people believe this kind of thing. I did take up psychology as an initial course of study years and years ago before I got more into electronics and physics and things like that. So I've had a smattering, but I need to ask Willie for some of these. I have some theories, have some ideas. Since I'm not a professional, I can impart it, but I think that most people just want to be part of the conversation. They want to appear as though they are worth talking to, worth listening to. They have some information to impart. Maybe you don't know this. Run into it a lot. Best thing you can do is, in some cases, try and be patient. If they're receptive, perhaps give them a little help along the way into learning something. If they're insistent, they refuse learning. A friend of mine used to say, shrug, smirk, and walk away. Now, Penn and Teller, I had a section here which video isn't showing, so I probably won't be doing this, but I'll describe it. Penn and Teller had a show in the 80s, late 80s, I think, whose name was reminiscent of this bird. Anybody know what this bird is? Yeah, it's a bush tit. Be careful not to mispronounce that. There is a video here of them. Maybe I'll show it, and maybe the people on the Zoom session just may not get it, or perhaps I can change my scope, but we'll see. I didn't watch this for very many of these shows because their name of the show was pretty much what it was. But this one I really, really loved. See if I could play it at least here for those in the room. Maybe. Let's see if it does it.
Okay, so here's my point. As Charles Darwin wrote, it is interesting to contemplate an entangled bank, clothed with many plants of many kinds, with birds singing in the bushes and various insects flitting about, and with worms crawling through the damp earth, and reflect that these elaborately constructed forms, so different from each other, and yet so dependent on each other in so complex a manner, have only been produced by laws acting around us. Thus, from the war of nature, from famine and death, the most exalted object we are capable of conceiving, namely the production of higher animals, directly follows. there's a grandeur in this field of life. Richard Dawkins' short description is, life results from the non-random survival of randomly varying replicators. Okay, now what's the creation story? You know, there's nothing.
I absolutely love that. Although I have to admit that my memory of that had him getting whacked by the Bible a lot harder than that appeared. But that's it. It was enjoyable. Any questions, by the way? Not that I can answer them or anything, because it's like.
Just a comment.
Yes, sir.
People are interested in J. Harlan Brett.
Yes.
There is a guy named, I guess, Brent, who's he's a professor of geology at Central Washington State.
Nick Zentner.
Zentner. And he, sometime during the pandemic, he decided to read Brett's stuff, and he had time on his hands, so he actually has done a whole series of videos, maybe 20 of them, where he reads the description that Brett's did and then takes you to like the different coulee or the different place that was being described and shows it to you. He is got
I will write that down
10
and watch it.
10 lectures about Brett. That's the only reason I knew about the scabbard.
Neat. Yeah, I was taken by the way that that Brett's even changed his name so he would appear to be more respectable. That he knew he had a uphill battle.
Well, he also tells a lot of detail. The sort of the incident you talked about.
Right.
He was basically ambushed by a bunch of USGS geologists, and he had to leave Washington. He ended up at the University of Chicago, which is where he got his PhD, and was sort of exiled to the Chicago.
Yeah, it's fascinating because, like I said, he had this absolutely wild, completely, obviously wrong answer that was right. He just needed a piece, and that was very cool. The geologists at the time were completely convinced that whatever happened on the Earth took hundreds of thousands, if not millions of years to occur. And Brett's is talking about something that basically went overnight. And it was just, just unbelievable. It's a great story all around. So cool. I will look that up. Nick Zentner. Look for those videos.
Zentner.
Perfect.
If you look up on YouTube, Nick Zentner and Brett, B-R-E-T-Z, you'll come up with the whole string.
Yep.
Some of them are like made within the last few months.
Cool.
Still doing it.
Cool. Willie.
This is all a part of the skeptic movement.
Yeah.
Which has been driven largely by magicians.
Yes.
It was Houdini spent the last third of his life debunking all these spiritualists. James Randi followed that up. And just last year, Jamie Ian Swiss put out a book on the latest stuff on skepticism.
Oh,
so
yes. Excellent.
Still a hot topic among magicians.
Have you seen this? Have you seen
I haven't seen that one yet.
Because I think it's the second chapter, Seeing, a lot of magic.
Well, and we're up against something else. We know there's a powerful motivation to want to believe in that stuff.
Oh, yes.
That your kids who got killed in World War I, you could talk to them, and that World War I was a big driver of all the spiritualism that went on.
Yes. Yes, absolutely. Anything else?
Jack,
Yes,
question. How many people were there in the room?
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
14, thank you.
Yep.
Question, can I be heard?
Yes, sir.
Okay, the Penn and Teller, what is the full title of the video?
Creationist. It's either creationism or creationist.
Okay. I'm gonna bring it up on my tablet here.
I
No, later on.
don't know. Yeah, I'll get it and put it in Slack or something like that. I can't vouch for the rest of the show past the intro, but I just absolutely love that intro. Yes, sir.
I
Mark.
was gonna ask if, you know, if you put up a list of the books you referenced.
Oh, well, easier just to have them right here because they're in different pages. But you know, set up all
No, I
of
mean, I wanna look at that.
Oh, later? Yeah, I could put them on Slack.
Maybe a book list. And maybe a list of, or just a source link of all the fallacies. I know you didn't, the list is so long.
Oh, you go to Wikipedia has one that's like 4 times longer.
There's also another website that has a very nice page for each one of the fallacies.
Yeah.
And so whenever you're arguing with somebody and they make one of them, you can send them the link. Your fallacy is, and
Yeah.
you know, straw man argument, and
Yeah.
it explains what it is.
When I listed them
No
out,
true Scotsman.
there is right here, logicalfallacies.org.
I don't know if that's the one that I.
It probably is. They're all
There are
over.
several,
There are,
but-
yeah,
But
but-
there's one with very nice artwork and.
yeah, but
There's also, I think there's another motivation that didn't quite touch on it, but there's for people who like to think that they're smarter than everyone else.
that's true.
And you know, I had this woman who runs a farm stand. She's, you know, a flat earther, you know, she's talking about gravity. It's just like, oh, you know, that's just a theory, you know, so, you know, she just kind of skips over the
Yeah.
fact that we've known it's been around for 2,000 years, you know.
Well, it's the change of theory too, like from.
Yes.
Theory has a different meaning than it.
Well, that was when I put up the
Right.
science,
People.
you know, when I put up the science
Yeah.
methodology chart, the comment I had, which I forgot to read, was you'll notice the word, you know, theory isn't in here anywhere. I think it was Richard, when I mentioned Richard Dawkins once, but he said they were talking about the theory of evolution. And he said people would say that it's just a theory. He says, no, it is triumphantly a theory. And so the theory is what happens when you have not been able to prove it wrong. Now, the instant you prove it wrong, it's gone. It vanishes, right? There better be a good proof. But until then, it's a theory because there's only one place that we can offer absolute proof,
But there's
and that's math.
The use of the word theory to mean hypothesis.
Yes, the theory, yeah, so the word we use in
It's
common
just a
speech
hypothesis.
is the same word we should use, hypothesis. I always try to use hypothesis when I can, if I don't do it all the time.
So along those same lines, what you put up for the scientific method
Yes.
is one way to do science, but I don't think of it as the only way to do it.
Oh, yeah, absolutely.
And in place of well, instead of a hypothesis or expanding on the idea of a hypothesis that some folks are getting interested now in using is a research question.
Mhm.
The problem with a hypothesis is you get specific like this, I think this will happen. And because you think that, you try to prove it. And if you get evidence against it, you are biased against that.
Right,
But then that means you follow the unsported path.
Right, that's-
No,
yeah.
but there's still a bias
Yes.
in your decision making
Yes,
of that.
that's
because
when you have
it's
to go back to
your-
Feynman.
So you can get around that by having a research question, which is, what happens when we do this? Now, you can view a hypothesis as a kind of research question, so it's included. It's
Sure,
not,
yeah,
it's not a contradiction or anything, but I've been using research questions with students instead of hypothesis.
yes,
The
yeah.
other thing that I'll say though is that I have some artwork in the lab that's fun, and I think you can probably find it online. Look up "Every Baby Knows the Scientific Method," and the woman who does this sells this artwork, and I bought it and put it in our lab. I don't know if you can find it now or I can post it to Slack. Your baby knows the scientific method.
There you go.
There it is. There we are.
Oh, come on.
So Etsy, go to Etsy because she sells these things.
Okay. They're not gonna make it big.
Well, when you
Oh,
go
there
to
we
her
go.
site, I think.
Um,
Oh, no.
That's
because
just a
she
piece of
stopped-
it.
Yeah, her kids are bigger now and so you're gonna have to find a cached version of it or something. That's the one on X.
Yeah, something went wrong. Yeah, it's
Yeah.
X. That's what went
It's
wrong.
called Elon.
Yeah.
Go to
Do image
images.
search.
Pick
Yeah. Oh, that's
image.
true. That's true.
There it is.
Let's see what we can get here.
Or baby art.
Oh, come on.
That's it. Weird baby art, yes.
Make an observation, form a hypothesis, perform an experiment, analyze the data, report your findings.
Oh, and share with others. You gotta,
Oh, Jay, yeah, that's okay. I'll have to look that up later. That's cool. Come on, give me a full picture. Don't make me, well, there's one.
there it is. Analyze the data, report your findings, and invite others to reproduce the results.
Yep. Yep.
Do you like broccoli?
That's key. Yeah, my scientific method wasn't meant to be the only possible thing out there. It was just the one that fit and found reasonably. There was a whole
No,
bunch of
it's
different
a
ways.
very standard. It's what's taught in all the
Yeah.
middle schools.
Yeah.
It's,
But the idea being that you know you don't get a theory first, you get a theory sort of last.
I'm gonna stop the recording.
Okay.